Okay, we are starting section 410, writing quadratic functions. First of all, if there is a quadratic function in vertex form, remember the vertex form is y equals a times x minus h squared plus k. You're going to plug in the vertex for h and k and the other point that's given for x and y. Then we solve for a and substitute a, h, and k back into the original equation. An example. First of all, think of the vertex. This is your h and k, okay? And then this point is going to be the x and y. So if you think about the vertex form, okay, this is the vertex form, just to remind you. Now when I plug in, it's going to be 14 equals a times negative 4 minus negative 6, okay, or you could even think opposite of negative 6. This is going to turn into plus 6 squared, and then minus 2 goes outside because that's the k. Now let's work this out. 14 equals a times negative 4 plus 6 is 2. 2 squared is 4. And then we bring down the minus 2. Now if I want to solve, I would have to add 2 to both sides. 16 equals a times 4. Now to get a by itself, we would divide by 4. So a ends up being 4. Okay? Now, I found out what a is. Let's take that back and plug it in up here. Okay, now we can use any point for y and x. So in our final equation, we want to make sure that y and x are in the equation. So it'll be y equals a is 4 times x. H is always going to be the same. The vertex never changes. I'm going to go ahead and write this as plus 6 because it's always the opposite of h. So it'll be x plus 6 squared. And again, k will never change. So that'll be minus 2 outside. So that would be the equation written in vertex form. Now if I want to write a quadratic function in intercept form, remember intercept form. Remember that p and q are the intercepts. So we're going to substitute in p and q, substitute the point in for x and y, and then again we solve for a and plug into the original equation. An example. If the intercepts are negative 4 and 0, this is going to be your P and your Q. Okay? This point is still X and Y. Okay? And just a reminder of the standard form, it's X minus P times X minus Q. Okay? So now I'm going to plug in, so it'll be negative 4.5 equals A times x is negative 3, and it'll be the opposite of p, so you could write minus negative 4, or you could just go ahead and turn that into plus 4 right off the bat. It's always opposite. And then we have x, negative 3, minus 0. Q is 0. Okay, do the work. We've got negative 4.5 equals a times 1 times negative 3. That's going to end up being negative 4.5 equals 1 times negative 3 is negative 3a. So now when I divide both sides by negative 3, I end up with 1.5 positive equals a. Okay? So now let's go ahead and rewrite the equation by plugging in the a. Y equals a is 1.5 times x, and again, p is never going to change. The x-intercepts always stay the same. And again, I'm thinking opposite, so this will be plus 4, and then we'd have x minus 0. Okay? Now to simplify this even a bit further, I know that x minus 0 is just x. So I'm going to go ahead and rewrite this as 1.5x, okay? I can change the order because this is multiplication and multiplication is commutative. So all I did was figured this out and put it here, which is fine. And then I still have x plus 4 left. So that would be the standard form of that equation given those intercepts and point. Now what about standard form? Standard form is y equals ax squared plus bx plus c. We're going to actually write a matrix equation to solve this one. And we're going to substitute the values back into the standard form. So we're given these 3 points. We want to remember standard form is y equals ax squared plus bx plus c. This time we have 3 variables we have to find. We need to find a, b, and c. To start out with, I have one equation. This is the x and y for the first one. 13 equals a times 2 squared plus b times the 2 plus c. Okay, so I just plugged y and x in, and I had 2 places where I had to plug the x in. Now we're going to go over to the next point, again still x and y, so it's going to be 27 equals a times 3 squared plus b times 3 plus c. And then the last point will be 55 equals a times 4 squared plus b times 4 plus c. Now I'm going to rewrite these equations so that they're a little bit nicer to look at. I'm going to have, usually we write these first if they're in standard form. So I'm going to go 4a, 2 squared is 4, plus 2b plus c equals the 13. Okay, rewriting this next one, we've got 3 squared, so it would be 9a plus 3b plus the c equals 27. And then we take 16a, 4 squared is 16, so it would be 16a plus 4b plus c equals 55. This is just a little bit better to look at in terms of 3 equations with 3 variables. So now if I want to rewrite that, I'm going to put this into a matrix equation. If you remember, the matrix equation starts with the coefficients, okay? So the coefficients of the first equation are 4, 2, 1. Remember, you want to have A column, B column, C column. Then we scoot down to the next equation is going to be 9, 3, 1. And then this last equation is 16, 4, 1. Now you're going to write the variables in a vertical matrix. The variables were A, B, C. And then we go equals the constants, which are going to be 13, 27, 55. Now you're going to want to take the time to put those equations into your calculator. Just to refresh your memory, that first matrix is A, this would be X, and the last matrix would be B. So put this in as a 3 by 3 matrix for A. You'd put this in as a 3 by 1 matrix for B. And then, quick refresher, if I want to solve for X, remember we take the inverse of A, that always has to be first, times B. Okay? And then we should get an answer for A, B, and C. Okay? So once you get all those typed into your calculator, and you take the inverse of A times B, if you do that on your own, you would find out that A, B, and C are 7, negative 21, and 27. Okay? So those are A, B, and C. Now if I want to finish this problem, I'm going to go back and plug in to the standard form equation up here. This is the standard form equation up at the very top in blue. So I want to rewrite this. It's going to be y equals A is 7, so it'll be 7x squared. B is negative 21, so it'll be minus 21x. And C is 27, so it'd be plus 27. And that is the final answer of this equation written in standard form. Now the next problem is work that we're going to be doing on the calculator, and we're going to actually make sure that we do this well together in class. So we're going to spend some time in class doing this specific problem. But those are the instructions for plugging into your calculator. You could go ahead and try this on your own and see if you can get that to work. So we would take this, you'd enter these points, these would go into L1. Okay, if you remember, you go stat, edit, plug those into L1, plug these numbers into L2. And then if you go back, notice the next step, you're going to go stat, calc, and then you're going to hit number 5, the number 5, and then enter. And then the cool thing is, on your screen, it's going to actually give you values for A, B, and C. Okay, it'll give you values for A, B, and C, and then you write the equation in standard form. Okay, and we'll do this together in class. Then the next thing is, if you want to actually work this problem out, you're going to have to use that model to predict the percentage of voters that'll turn out in 2004. And again, we'll talk more about this problem in class when it's practice day for section 4.10. These are the problems that you'll be working on for section 4.10. This concludes the notes for now for section 4.10.